before we get started, the name of the class was Impacts of Climate Change and Aridification. And aridification is a term that a lot of people don't know, and that's why I wanted to put it in there, just to make sure that you were introduced to that term and knew what some of the discussion was going to be about. I think that the easiest and simplest definition I found for it is it's the process of a region becoming increasingly arid or dry, and it refers to long-term change rather than seasonal variation. So obviously there's a lot more about impacts of climate change than that, but that certainly is something that's affecting us. As you take a look outside in the next few days and you'll see examples of what we're talking about when that happens. So that's why that's in there. So we have a whole list of experts that are going to be coming to present in the 5 sessions we're here. And there's a lot of information coming out now, just a tremendous amount. It's almost impossible to keep up with these 3,000-page documents that are coming out and absorbing the important parts of that. But I think we've got a good cross-section of people who have probably done a lot of that reading and a lot of that research that goes into that. And we're lucky to have them. But overall, it kind of paints a pretty bleak picture of what we're seeing right now. Things are accelerating faster. We're at a point where we didn't know we would be necessarily a few years ago. So we're going to address that. See if the future is all that bleak, if there's something we can do, what the likelihood is, what to expect, and discussion like that, wherever the discussion might take us or the questions and answers might take us would be great. It's appropriate that our first speaker here is a friend of Ollie. He's been here quite a few times, and he and I think we're both surprised when we saw you haven't been here for 2.5 years. You said something like that. So I think I was a little lax during the pandemic and trying to keep visitors down a little bit, maybe. But David Feldman over here, Professor Feldman, came to UCI in 2007, and from 2007 to 2016, he served as professor and chair of the Department of Planning, Policy, and Design in the School of Social Ecology. And they recognized the excellence there, and in 2016 added a few more things to his list of work to do. He's now a professor of urban planning and public policy. That's one department, and also in Department of Political Science. So 2 departments that he's a professor in. He's also, very importantly, the director of Water UCI. And I think the last time you were here, I think you're probably talking about Water UCI and what that was. And also the director of the Masters of Public Policy program since 2020. So but before that, a lot of academic and research positions at University of Tennessee, Oak Ridge National Laboratory, Morehead State University in Minnesota. That's kind of up there by Fargo, isn't it? Yeah, right across the river. Yeah, and a Bachelor of Arts in Political Science from Kent State University. Those first 2, by the way, were University of Missouri in Columbia. And just as a historic perspective, well, he was at Kent State as an undergraduate. He was there on the campus when the shootings took place. So it's always nice to kind of rub elbows with history there. And Dave was at the university at that point. Okay, specializations, areas of research interests, very broad: water resources management and policy, global climate change policy, ethics, environmental decisions, adaptive management, sustainable development. And I would like to add one more onto that, his dedication to teaching seniors. And we were able to get him back basically whenever we asked him to come over. So we really appreciate that. And teaching is a very important part of that. In addition to those, he has a CV with over 35 pages of his recent publications and articles, research reports, presentations, committees, awards, and all of those sorts of things. I was hoping to read that to you here, but I think we're going to run out of time. I can only do 20 pages, but would that be okay just to do the first 20? Okay. Well, at any rate, we really are happy to welcome Dave back. So please join me and welcome back Dr. David, Professor.
Thanks. Nice warm day today, isn't it? Get used to it. Going to be more of those. So just a couple of things. The mention was made of aridification, and we are going to touch on that today. But I want to make note of the fact that when we talk about climate change in water, you're going to see some examples of this. It's not only too little, but in some instances too much. Climate change, the one thing that we know is true, both globally and in California, as you're going to see, is basically chaotic weather, extremes. We've already seen this in California in the past several years. We're going to see more of it, and we're also seeing it globally. In addition to talking about the impacts of climate change on water, I'm going to devote my remarks today to what we can do to fortify or make resilient our remaining water supplies in the face of climate change, and some of the issues that are attendant to that. For those of us who live here in Southern California, and particularly in Orange County, we know that there are some growing concerns, I might even say controversies, over options regarding what to do about our water supply. Should we build a desalination plant in Huntington Beach? Big ocean out there, a lot of water. That might solve our problems. We already recycle a lot of wastewater in Orange County. That's our primary source of drinking water. Hope you all had your breakfast when I say that. And it's not very controversial here, but it is controversial in other parts of the nation and California. And last but not least, when it does rain, and particularly when we get these more intense storm events, which is likely with climate change, can we capture, store, and harvest that rainwater for dry periods? So those are just some of the things we're going to be talking about. Lastly, I do want to make mention of the fact my center, Water UCI, we have a website. I would invite you to take a look at some of our events, our research. We have a lot of public outreach activities. We have one coming up on global change and water conflicts globally in a couple months. So I invite you to look at that. We do also record our colloquia as well. So I want to start off with a welcoming and some things that often come up when we have debates or discussions about climate change. My favorite one is the one on the top left. Created a better world for nothing, at any rate. It would be amusing if it weren't true, but in fact, I think these cartoons capture a lot of the current debate over climate change, either the fact that it's much ado about nothing, or we're going to will to our grandchildren and our children a world very different from our own, which is truly likely, and that we're either going to do something about it or we're not. So let's get serious with just a moment, and I don't want to spend a lot of time on the sources and the causes of climate change, but I think it is worthwhile to just review some of the facts so we're all on the same page. Because when we talk about climate change being responsible for our weather, and we talk about climate change being responsible for our conditions with respect to water resources, we need to know a little bit about what we're talking about. At the bottom of this slide is some information from the United Nations Intergovernmental Panel on Climate Change on CO2 emissions. Anthropogenic simply means human-caused carbon dioxide emissions. And as you can see, beginning with the Industrial Revolution in the middle of the 19th century, those emissions have grown precipitously and continue to grow. They continue to accelerate, even as many developed countries like the United States begin to plateau their carbon emissions. Developing countries are increasing their emissions because they want and need to develop. The problem isn't just emissions, however. As the top graph indicates, it's the fact that greenhouse gases, including carbon dioxide, remain in residence in the atmosphere for long, long periods of time, creating what we call greenhouse gas concentrations. And the concentrations have increased right along with the emissions, which also implicates carbon dioxide in the problem of global climate change. So what? Well, land and ocean surface temperatures are increasing. Sea levels are rising. These are things that are very definitely implicated by climate change. On both of these slides, you'll notice a kind of a this business. That's seasonal, okay? The overall trend is upwards, warmer. But of course, during the winter, there is a slight cooling. So let's turn to climate change and water. And this is some information I've distilled from the Intergovernmental Panel on Climate Change, which is a United Nations organization that shares scientific information across national boundaries, and as a result has a lot of credibility to a lot of us who study climate change and study its impacts on water resources. These are some direct quotes from a report from the United Nations Intergovernmental Panel on Climate Change. And I just want to highlight some of these that implicate water. Widespread impacts on human and natural systems. That's pretty significant. The atmosphere and the ocean have warmed. Alluded to that on the previous slide. And think about this one. The amounts of snow and ice have diminished while sea level has risen. What's the principal source of fresh water in California? Anyone know? It's not the tap you turned on this morning. I just feel caution. It's the Sierra Nevada. That's really the state's reservoir. If we have less snowpack, and we don't have a lot of snowpack in the Sierras right now, and we haven't for many years, that means we're going to have less snow melt in the spring when it's needed. But we have had a lot of rain. Unfortunately, that rain can't be captured and harvested the same way snow can. So this is a problem. Snow and ice have diminished, sea levels have risen. Think about this third bullet. Increase in warm temperature extremes, an increase in extreme high sea levels, and an increase in the number of heavy precipitation events in some regions. As we're going to see, the problem with water management and climate change is not only too little in some places at some times, but again, too much in some places at other times. Which brings me to this last bullet, which is one that is near and dear to my heart, because as a political scientist, I'm concerned about the impacts of all of these on people, and particularly people who are in less fortunate circumstances than we might be, which is to say their ability to adapt to these changes are far more constrained than our own ability to respond. The risks are unevenly distributed and are generally greater for disadvantaged people and communities in countries at all levels of development. This, to me, is the heart of what we mean when we talk about climate justice. Many of you have heard that phrase, climate justice, climate change and environmental justice. What are they talking about? This is what we're talking about. We're all going to feel the impacts of a less predictable water supply now and into the future. But communities that are already under great stress in terms of accessing safe, potable water supplies are going to be under much more dire circumstances in the future. Very quickly, sea level rise and its impacts. Obviously, sea level rise affects coastal areas. These are some projections from the National Oceanic and Atmospheric Administration, which is the principal federal agency that monitors and tracks global climate change trends. And basically, all this figure is meant to suggest is that depending on how warm the global climate gets, and we don't know, there's a lot of uncertainty on that fact, but depending on how warm it gets will dictate how much sea level rise increases over the next century. The one thing that seems to be certain is, while there's a lot of possible variation in how high it can rise, coastal areas, particularly in vulnerable states along the Gulf Coast and the Atlantic seaboard, will be extremely vulnerable to sea level rise. This will also have an impact on freshwater supplies, because as the ocean increases, you're pushing salt water into estuaries and river systems. That will have a dramatic impact on coastal cities and their water supplies. And most wastewater treatment systems are along estuaries and rivers. So this is going to put tremendous pressure on what we commonly call infrastructure. Some places like New York City are already in the process of planning for the spending of billions of dollars to rethink their intakes of water supply into the city as a result of global climate change, and also how they will treat wastewater. Boston is another one that's going through this scenario. Polar ice melting and sea level rise. One of the things that I think is significant about these two slides is how much polar ice has diminished in the past several decades. It's quite dramatic and certainly is another implication of climate change. And one of the problems, according to a lot of scientists, is that this melting and sea level rise may have reached a tipping point, which is to say, even if we were somehow to avert further global climate change right now, right this moment, if we were suddenly to transition into a carbon-free economy and use all renewable energy sources, the fact is we've already exceeded a certain tipping point, and the warming effects that have already taken place will be irreversible. So this is a huge problem, huge challenge. What it means is that we can't avert or prevent climate change. All we can really do is to avert it getting even worse than it is now. So that's something to be thinking about. Tipping points, irreversibility. So I want to talk about some international impacts, some global impacts of climate change. This is from a fairly recent report by some friends of ours at the center at UCI. Peter Glick works at the Pacific Institute up in Oakland, California, and Charles Iceland and Ayuti Trivedi are some colleagues of his. And one of the things that they note is that climate change may already be causing international conflicts over water. When we talk about Syrian refugees moving from rural areas into cities and leading to the civil war in Syria, we may in fact be seeing climate refugees that have abandoned rural areas for cities, causing political tensions, putting pressure on governments, largely because of chronic drought, which is driving them off the land. Likewise, when we see Guatemalans migrating into Mexico, and in turn putting increased immigration pressures on the southern border of the United States, these aren't just refugees seeking asylum. These are, in some instances, climate refugees who are tethered to the land and who are also tethered to available water supply. This article on the right, which actually came out of the LA Times a couple of years ago now, about a year and a half ago, notes that even in Mexico, there has been violence attending rationing of water from water supplies that happen to be shared with the United States, that is to say the Colorado River. So this could be a portent of the kinds of things that we need to be thinking about, that we need to be worrying about. It's not just water, it's not just climate, it's also global politics as well that's implicated in this. Looking at the Western United States, I mentioned the Sierra Nevada, which is our primary source of water supply here in California. But in fact, the entire Western United States is really subject to these same pressures. I want to explain this little chart, which came out of a report from the Global Change Research Program. Actually, my center and myself, we had a little bit of input into this report, not into this particular map here, but some other information that went into this report about water stress in the Western United States and some of the options that we are open to us in light of climate change. But at any rate, what this is a projection of how climate change over a long period of time meaning all the way until the end of this century, 2099, will affect snow water equivalent. And basically what you can see is that if you use from the 1971 to 2000 period as a baseline with 100% projected snow water equivalent available throughout the year in California, in Nevada, in Utah, and Colorado, New Mexico and Arizona never had that blessing because they don't have a lot of snowpack, obviously, because of their baseline climate. But over time, you see a dramatic shrinking of snow water equivalent. In the case of California, by the end of the century, less than half the available snow water equivalent is projected to exist. And this is true throughout the West. Two things to note here. The less snow water equivalent, the less water, period, that will percolate into our groundwater basins and into our major rivers that are our sources of water supply throughout the West. And a second thing, these 6 states share one river, the Colorado River. And in fact, all of the snow melt, or not all of it, but a lot of the snow melt from these various states ends up in one way or another in tributary streams that feed the Colorado River. So less projected snow water equivalent, less water in the Colorado River, which means less water supply for all of these states. So it's kind of a double whammy. These are some illustrations of this problem. This is a complex figure. I want to spend a little bit of time on it. The United States Bureau of Reclamation is a federal agency that operates most of the large water projects here in the Western United States, including Hoover Dam. If you've been to Las Vegas, you've seen Hoover Dam, of course, one of the largest engineering structures in the entire United States. At the time it was built in the 1930s, it was the world's largest dam. It's now subsequently been eclipsed by dams in China and Brazil and Ethiopia, elsewhere. But nevertheless, a huge water project. If you go back way back to, let's go ahead and play with this pointer. If you go way back to 1935, when the dam was actually completed and began to fill, you can see that the Colorado River's average height above sea level grew dramatically. There have, however, been periods of drought. There was one in the 1940s, another one in the late 1940s, another one, you can keep going on and on and on, and these things are periodic. So periods of feast or famine are common in the Colorado River. This was known by people when Hoover Dam was built. But here's the problem. This valley seems to be virtually interminable. It's never recovered to the pre-drought levels. And subsequent to 2015, it's actually continued to decline, as we're going to see in a moment. This is a portent many hydrologists believe and climatologists believe, and more importantly, water managers, the people who actually use the water from Lake Mead behind Hoover Dam and other impoundments along the Colorado River. This is a portent that there's going to be simply much less water in the Colorado River to harvest for the use of the states that depend upon it, including us here in Southern California. So this is very bad. And you might say, well, that's an interesting figure, Dave, but could you make this a little bit more graphic? I'll try. These are two pictures of Hoover Dam, 5 years apart. I took both these pictures. I drove all the way to Las Vegas just to see the dam. Okay, don't believe that. But at any rate, I did take pictures of the dam. And this bathtub ring is symptomatic of the decline of inflow into Lake Mead, or the reservoir created by Hoover Dam. Two things I want to say about this. The water that's stored in Lake Mead is, when Hoover Dam was built, the goal was to store the equivalent of 2 full years of flow of the Colorado River. That was the goal, 2 full years. Now, the reservoir, which is, by the way, even lower than in this picture I took in the fall of 2020, the reservoir is now at about 40% of its elevation. If it continues to fall, and it might, these towers here, these are called intake towers, not only take in water to go through the dam and out through the downstream Colorado River as shown on the left, but they also generate electricity. And if the water level should fall about another 15 feet, Hoover Dam will be unable to generate power. So the water energy nexus we often talk about when we talk about climate change and water. No water, no electricity. Okay. The largest consumer of power from Hoover Dam, us. We edge out Las Vegas. Las Vegas does get power, obviously, from Hoover Dam, but so do we in Southern California during peak periods, meaning in the summer when it's warm and we use air conditioning. So think about this one. Temperatures go up, more demand for air conditioning, more demands for power, less water. This is a bad fix to be in, but this is precisely the fix that we're kind of headed toward. And worse, as noted on the caption of this slide, these extremes we think may be the new normal, as indicated by the previous slide. In other words, we're not going to go back to a time when Hoover Dam's elevation went right up to almost 1,200 feet above sea level, or almost to the roadway at the top of the dam. That won't happen anymore. This impoundment will basically be sort of half filled. And another story that's kind of interesting, Las Vegas, which is one of the country's fastest growing cities, which gets its water supply also directly from Lake Mead. They are so worried about this that they are in the process of completing a new intake. And instead of the intake taking water from the side of Lake Mead, which is what most intakes do, they're actually tunneling underneath the lake. It's kind of like the drain in your bathtub. Think about that one for a moment. This is very serious stuff. So this is what we're facing in the West.
Dave, I do have a question from
Go ahead,
the audience.
shoot.
It's the first graphic you put up, and it says, what happened in 1950 to accelerate these changes? I think that's kind of pertinent to what we're looking at here.
Which one was this now?
The first graphic you had right off the bat, way up in front, and it came in about that time. But what happened to all of a sudden accelerate that change in climate?
So let's go back to it. This one?
Pretty sure that's what it is, yeah.
Yeah. What accelerated it after 1950? Developing countries gaining their independence and rapidly seeking to industrialize, and doing so with carbon-based fuels. China, India, Nigeria, Brazil, Indonesia. These are large carbon dioxide producers. Right. So industrialization, it's a trade-off. Many developing countries would say, well, okay, we could halt our development, or we could transition to renewable energy. We're not going to halt our development. We could transition to renewable energy with your help. But if you're not willing to step up to the plate and help, we have no choice but to continue to consume carbon-based fuels. In India, have you ever been to India? In many of India's largest cities, electrical power is shut off at various times during the day, except for hospitals and schools and special facilities. Why? Because they simply cannot keep up with the growing demands of their own society. And they don't have a lot of alternative sources of energy. So this is just an illustration, but that's what's basically happened. Yeah. Any further questions on that, or on any of what we've talked about thus far? Happy to pause at any time to take questions.
I'll throw one in on this one.
Yep.
Hang on a second until we can get it. Oh, go ahead, Carolyn. I didn't see you. We require this because of the video we're doing. We have to hear those questions.
It took me a while to figure out that we were looking that way, and now on the right, we're
Right.
looking the opposite.
That's
way
correct.
to find the towers.
So on the left, downstream view, on the right, upstream. Yeah. Yeah. Coming your way.
Yes. Is anyone researching how much of this reduction is due to reduced rainfall and snowpack versus growing communities upstream that are pulling more water
Yes.
out before it ever gets to the Colorado?
Yes, in fact, the Bureau of Reclamation has done that research, and it's a great question because the answer is both. Very simply, as the supply is diminishing, the demands are growing. And what you're actually getting is there is now a situation where demands for Colorado River water have actually exceeded the supply. As a result, various states, including lower basin states, Nevada and Arizona, most recently, and we'll talk about that momentarily, have actually been ordered to cut back. So yes, great question. Diminishing supply, growing demand. Demands have not diminished. They've grown. And that, of course, includes us here in Southern California. Yeah. Yeah, a lot of research, and this is what really makes it problematical. You know, we could say, well, we'll use less water, which we should, perhaps, but there are lots of needs for water that are non-negotiable. I mean, you simply have to have water for certain things. So this gets us to the alternate supply issue, which we're going to talk about in just a moment. Good question. I mentioned weather extremes. We worry about drought. In Bangladesh, they worry about floods. And this is a triple whammy. Declining snows and more rapid snowmelt in the Himalayas, rising sea levels, and an increase in tropical storm intensity, typhoons in this region, all of which lead to this. This is something that is very common, very common in Bangladesh and also in parts of India and also parts of Southeast Asia. So flooding, more extreme and frequent flooding events is something that we're likely to see in various parts of the world. And there is drought. California is not the only place in the world, nor is the Western United States the only place that has suffered severely from climate change. Australia, and I've done some research with some colleagues in Australia and some colleagues here, looking at ways in which Australia has managed chronic drought. In the early 2000s, Australia underwent a drought that was so severe, it was actually given a name. It was called the Millennium Drought. And the reason it was called the Millennium Drought is because scientists in Australia believe it was the worst drought in 1,000 years. No way to really prove that, but from all the hydrographic records, it seemed to make sense. And you can see the figure on the bottom tracing how bad this drought was from the early 2000s, really through the end of the decade, really, really terrible. The effects were most dramatically felt in what's called the Murray-Darling Basin, which is Australia's breadbasket. And the Murray-Darling River is sort of the equivalent, their equivalent of the Colorado River. So this is an area that was terribly, terribly oppressed by drought. And it not only affected agriculture, but it also affected urban areas in Australia that depend heavily upon the Murray Basin for water supply. Melbourne and Adelaide, in particular, two cities that suffered severely from the drought. And you can see the effects, Dust Bowl effects, very, very, very severe. The basin accounts for about 1/3 of Australia's agriculture and about 60% of Australia's irrigated land. By the way, subsequent to the drought, this is very interesting. Australia, I'll go ahead and mention this now. I was going to allude to this later, but this is a good point at which to talk about. Prior to the Millennium Drought, Australia had a system of water rights that was very similar to that here in the United States, and in particular, very similar to that here in California. basically, if you owned a piece of land and a stream traversed that land, you were entitled to draw as much water off that stream as you could, subject to other landowners that also had lands adjacent to that stream. We call that riparian rights. In addition, you were able to draw water from underneath your land, the groundwater basin. After the Millennium Drought, Australia got rid of their water rights system. They replaced it with a permitting system. Now, if you're engaged in agriculture, you're required to have a permit from the state, from the government, from the state governments. Here we would be South Australia, Victoria, New South Wales, these particular states have these rules where you have a permit. And basically the permit says you can withdraw so much water in the course of a year and no more. And if you aren't able to use that much water, if you don't need it, you can actually trade your water rights and make money doing so. So a water market. It's a very innovative system. But it was a system formed out of somewhat, we could say, desperation.
Dave, can I just make a comment about those last two slides? I have in-laws that are macadamia nut farmers on the East Coast there and the Gold Coast.
Mm-hmm.
And the last 2 weeks, they've had 2 meters of rain.
Right.
After this millennium
Right.
flood occurred. So they are really a great example of this swing.
Exactly right. And terrible flooding. And one of the effects of the terrible flooding, because they went through this horrible period of drought in South Australia, New South Wales, Victoria, and Tasmania, which is this island right here, which is another Australian state, there were wildfires. And then the wildfires, of course, consumed a lot of the vegetation that held the soil. And then when you had these intense rains, you had terrible mudslides and all kinds of inundation. Sound familiar? Yeah, just like what we have in California. Very much the same. So a lot of affinities, and we see this worldwide. This is a situation that I wrote about, and many other people have written about. South Africa, and in particular the city of Cape Town. Cape Town, a couple of years back, nearly 4 years ago now, as it turns out, almost completely ran out of potable water because of chronic drought caused by climate change. And people were queuing up for water because their domestic supplies were literally shut off by the government. There was a return of rainfall, fortunately. There was also aggressive water conservation and water rationing. And South Africa, and in particular the Western Cape, the region surrounding Cape Town, is slowly recovering. But the bottom line here, and this is sort of embedded in this slide, but it's a little difficult to read, is that Cape Town and the government of South Africa generally took this terrible, terrible event, which led to what South Africans were calling day zero, the day when the city would theoretically exhaust its water supply, when the region would theoretically lose its water supply. They took it as an opportunity for change. What change? Well, they're now recycling wastewater for non-potable purposes at an aggressive rate. They are, and they really don't have much choice, building a series of desalination plants, some of which have been on the drawing boards for years, but were stalled for a variety of reasons. So they are building desalination plants. I say they don't have much choice. There aren't many other options really open to South Africa, to the Western Cape region at least. Mediterranean climate, similar to California, but even more arid, naturally. And they're also doing a better job of managing what they call river basins, or in South African parlance, catchments. That's what they call river basins or watersheds. And basically what they're trying to do is to make sure that conservation policies have been enacted that are enforced very rigorously within the region. So this is almost like something out of a science fiction movie, but it was science fact. Very bad situation to be in. Other cities have faced similar events. Sao Paulo, Brazil, about a year and a half, 2 years ago, faced something that was comparable to what Cape Town, South Africa is going through. And Melbourne, Australia, a city that I'm very familiar with, nearly went through this as well. I mentioned the Southwest. This is a lot of detail here to read, but basically, I like the headline. This is from the Arizona Republic. This was an article about a year and a half ago. I think the headline says it all. The pie keeps shrinking. You know, do you want one slice or two? Well, it doesn't make any difference if the pie is smaller. Lake Mead's low level will trigger water cutbacks for Arizona and Nevada. And in fact, that's exactly what Arizona and Nevada have had to do. Under rules of the Bureau of Reclamation, basically states that have senior water rights or were settled earlier, like California, have access to a greater supply of water from the Colorado River than do Arizona and Nevada, which are junior appropriators, and until recently, very small states in population, but over the past 3 to 4 decades have grown considerably. They have had to cut back how much water they can draw from the Colorado River. Any of you been to Las Vegas recently or in the last couple of years? You cannot have a lawn in Las Vegas. It's not permitted. You have new housing, you have to have a desert landscape. Okay? Golf courses, recycled wastewater, totally. No fresh water. Go to the Bellagio Casino, those great fountains, don't wade in them. That's recycled wastewater, not good for your health. Very pretty when it lights up. And aggressive conservation. Also, Las Vegas does capture rainwater. They're quite aggressive about it. They basically capture the water. It flows into Lake Mead, and then basically it's banked. The amount of rainfall, they calculate how much volume of water that is, and that's how much additional water they can draw from Lake Mead. Phoenix, not quite as aggressive as Las Vegas is on water conservation, but they're beginning to get the message. And they do a lot of recycling of wastewater in Maricopa County in southern Arizona as well. But this is something that we want to keep an eye on. Last week, I was invited to be a panelist on something called the Orange County Forum. I met over in Newport Beach, and the general manager of the Orange County Water District, of the Irvine Ranch Water District, and of the Santa Ana Watershed Authority were on a panel, and I was on the panel. And one of the things we talked about is the fact that as this continues, California will be required to also cut back how much water it can use from the Colorado River. So again, dire. I want to talk a little bit about some things that probably most of us haven't spent a lot of time thinking about. Maybe some of you have, but I'll tell you, when I share this with my students, they're kind of surprised. When we talk about climate justice, think about this one. In most of the rest of the world, women are responsible for providing water to their families, women and children. It's called fetching. Literally, they're the ones that go out to the wells or to the ponds or to the streams and bring water back. And there are all kinds of implications, as you can read here. Less time to share in terms of the sexual division of labor, less time to share power in terms of politics, more burdens on women and children, less time to get an education, for example, or to have an income generating job because they're responsible for water. Girls spend over twice as much time as do boys, adult women 4 to 5 times longer than men. So we're talking about gender justice, water supply, and climate, huge issues that are affecting much of the world. And I alluded to this earlier, but I want to mention it again. Climate change and migration, mass migration, in this case from Darfur, South Sudan. It's believed that there's definite evidence that chronic drought through climate change is causing mass migration. And the World Bank has done some research over the last couple of years suggesting that depending again on how warm the climate gets, there could be increased migration from mostly southern hemisphere countries into northern hemisphere countries. It's estimated that the numbers could range depending on whether or not we adopt climate-friendly policies or not, from some 50 million to maybe nearly 120 million migrants from drought-stricken countries in years to come. So these are all pretty frightening statistics. Don't share them to scare you, but to get you to realize that this is truly a global issue that affects water, that affects agriculture, that affects all of the activities that depend upon water. And very briefly, we always get asked, I always get asked, or often get asked as a political scientist, well, why don't we do something about this? And I'm not going to spend much time on this slide, but I think it's good to kind of catch us up on this. There has been a lot of research on how political values and political ideologies play into this debate. And you can read these figures for yourself, but a number of organizations, including the National Opinion Research Center, which is based currently at the University of Chicago, has done a lot of research. And when you ask people whether climate change is caused mostly by human activities, it turns out that there are very definite differences in terms of political party affiliations and how people respond to that question. And on the other hand, there are also very severe differences in how people believe that weather-related disasters are caused by climate change. This is one of the reasons, ironically, that some of the very states that are most subject to the pressures upon things like water supply from climate change are also the states taking the least amount of action in climate change. So states in the Southeast, for example, Southeastern United States, or the Midwest. California is clearly an outlier. We're a state that is suffering the effects of climate change, and we get it. We're also, as the journalists say, a blue state, okay? Not taking any partisan position here, but simply making us aware of the fact that for some reason or another, this has become an ideological issue, an ideological divide. If it makes you feel any better, that divide exists in other countries as well. And it turns out that, in fact, in most surveyed countries, where the majority of the population sees climate change as a major threat, there are countries that are heavily agricultural, heavily subject to sea level rise and water stress, and also countries that have large agricultural sectors. Interestingly enough, and this was interesting to me having been there, Israel does not consider climate change to be a major threat. Israel's right there at the bottom. It does consider it to be a threat when you put those who feel it's a major and a minor threat together. It's still a majority of the population. But I've asked colleagues in Israel, and they say the major reason, and we're going to come back to this in just a little bit, particularly in the second hour, because Israel has actually taken very aggressive measures to make their water supply system resilient. So when we say they don't feel it's a major threat, that doesn't mean they don't believe there's a problem. They definitely believe there's a problem. It's not a threat because they've taken measures to adapt to the problem. which is a big difference from many other places around the world. So nevertheless, a lot of threats. You notice in the United States is kind of down toward the bottom. So yeah, South Africa, we mentioned Cape Town. When this survey was done in 2018, unfortunately, South Africa still, a majority did believe it was a problem, but not as high as some other countries, much more subject to the vagaries of climate change and water, Greece in particular. Greece, of course, much of the land area is in the form of small islands and peninsulas, which are subject to sea level rise, and also chronic drought, that part of the Mediterranean basin. Opinions on the seriousness of the problem reflect similar divides, we think. People who perceive a direct threat from climate change are more likely to see it as a problem. And as I note here, their countries are more supportive of a global treaty to do something about climate change. So again, the United States toward the bottom. Questions, comments about any of this before we move on? Yeah.
Any good news?
Any good news? That's coming up. I don't know if it's good news, but let's say it's more positive news, hopefully more positive news. So here's a solution. I couldn't make this up. This is an idea that's been proposed from time to time. After all, with global climate change occurring, we know that pieces of the Antarctic ice shelf are breaking away, creating huge icebergs. Why not tow one of these puppies to San Diego? And as it melts, I don't know, that'll be your water supply for the next 250 years or so. Well, I don't know how long it would last. This came out of Bloomberg Business Week. As you can see from the text here, this is an idea that actually goes way back to the 1940s. The Scripps Institution, which is now part of the University of California, our system in San Diego. The Scripps Institution began exploring the possibility of towing an iceberg to San Diego to mitigate California droughts. I think it's interesting that this thinking has gone back that many decades, but it indeed has. But this particular proposal was conceived during South Africa's drought, day zero that I mentioned before. And it was conceived by a South African businessman. It would cost, as you can see, about over $200 million. It would require an agreement to buy the Antarctic water, agreement with the country of South Africa. A couple of quotes. One official says such a project is both complex and risky with an anticipated very high cost. Greatest challenges pertain to containment and transportation of the meltwater as well as its injection into the water supply system. And others suggest, well, we do need to look beyond traditional sources. Whether this is the solution is a good question. So I'll give you my opinion. No, this is not the way, okay? This is a little unfeasible, a little ridiculous. But I throw this out there to show you something about how desperate some people are looking at the measures of how to adapt to climate change in terms of our freshwater supply. So we're coming up on a break. And so let me leave you with this slide. I want to talk through this just a little bit, and then we're going to talk about some things that can be done. My center had a conference the last time California went through a drought, the last one back in 2015, 7 years ago. We had a conference in which we brought in people from universities throughout California and various agencies around the state to talk about what we could do in terms of understanding droughts and managing them in the future, given the fact that they're likely to get worse, as we've seen with climate change. And we also published an article in a magazine called Nature, Water and Climate Recognize Anthropogenic Drought. And basically, our theory in this article that came out of this conference is explained in the text on the left. And let me kind of walk you through this. Droughts are natural. Droughts will always occur, whether we had climate change or not, we would have droughts. But climate change is definitely making them more frequent and more intense. We're seeing that now. But here's a kicker, second bullet. We make them worse, not nature. I love when people use it as act of God. Let's blame God. That's a good start. No, let's look in a mirror, okay? Our behavior worsens the effects of drought. How much water we use, how we use it, where we apply it. And ecological impacts are also significant. This is a message that seems to get very lost in the debates over climate change and water. The impacts on people can be severe, but the impacts on fish can be even more severe. And the last time I checked, fish tend to need water every day, okay? Sea life, other species. So what is it that we need to do short of icebergs, towing icebergs? And the answer is we need to find options that will give us resilience. I use the word resilience and not the word sustainability. Sustainability is a word we love to use when we talk about in the environment. Sustainability assumes you have something to sustain. I want to submit to you, we don't have something to sustain. We have less water, and we're going to have less water to use in the future. So what we want to do is fortify ourselves. That's why I use the term, and other colleagues use the term resilience. And resilience can be defined as a transition to renewable sources of water and low energy water sources. Keep that in mind, because when we talk about desalination, we're going to talk about how feasible that really is as a long-term option. Do you solve a problem by creating a problem, or do you solve a problem by not creating a problem? And integrated demand and supply management. In other words, find more sources of water, but also do a better job of saving and conserving the water that we have so it can be renewed. How do we do that? 4 keys. In the second hour, we'll talk about these keys in detail, but we need to conserve water and avoid waste. Shut off that lawn sprinkling system when you don't need it. We need to become more efficient. We need to reuse every drop of water. And we need to harvest new sources where we can find them.
I wanted to say a couple more things. I kind of shortchanged Dave because nobody would let me read those 30 pages, but he also has 7 books that he's written over the last couple decades or so. And I won't read those all off, but if you go to UCI faculty, Dave Feldman, you'll see the list of all those things, plus many, many more things. He also works, as you have found out, internationally quite a bit and has done a lot of traveling to countries with water problems. And you'll see a lot of reports and references and things that he's done in that part of his life doing that kind of research too. So all available on his website for those who want to dive in a little bit further. The other thing is I saw this California drought up there. I just wanted to plug next fall in November, I'll be doing a class called California Drought. And I'm thinking of changing it to Mega Drought, and you'll find out more about that as I get closer, and as Dave maybe talks about the possibility of that. But I'm going to talk about what's going on, and by that time, I'm sure we'll have a whole new set of graphics. I'll have to go back and change everything I've had to reflect the current. But we'll get into a little bit more detail, just specifically on that drought question. So keep that in mind too when you're registering next year. So Dave, take her away. Doing great, by the way.
Quick story: when I was invited to apply for a position here at the University of California as the chair of the department that I'm now a member of, they said, you ought to come to California to study water. It's a great place. I came here and I realized they were lying. You don't have any water. So no, just kidding. No, great, best decision I ever made. So resilience, transition to renewable low energy sources and integrated supply and demand management. So I want you to think about some things before we go through some of these options. In the process, I think you can kind of answer your own questions about what we should do here in California and globally. I'll give you my bottom line right now. There is no panacea. There is no quick fix. And the fixes that you need or the remedies that you need depend on where you live. Some remedies fit certain places better than other remedies. That's not necessarily an earth-shattering conclusion, but I think it's an important one, and it's one that we often overlook. People often say, well, why not just pump water from the Great Lakes? Well, I grew up in Cleveland, and I can tell you that that would not be an option that Northern Ohioans would favor. Why don't we just build a desalination plant every 10 miles along the California coast? Well, hold that thought. Lots of reasons why we might not want to do that. But these are the things that make an option resilient. We can think of them as a screening tool, or at least I do in the research and writing I do. You want to look at technical feasibility. Do the science and engineering support the application of a certain option? There are lots of options that pass the engineering test. Yes, we can desalinate seawater. Yes, we can recycle wastewater. Yes, yes, yes. But what about the cost? Is it affordable relative to other likely alternatives? As a water manager, as a government official, you have to think about how much these options are going to cost and who's going to pay for these options. There's a lot of variation. So these are practical, political, and economic questions where the rubber meets the road. They're societal questions. And all of you know, there are environmental impacts and risks. Desalination has some environmental drawbacks. Recycling of wastewater has some potential health risks. The question isn't, does an option have risks? The question is, can those adverse impacts be mitigated? If they can be mitigated, that's a plus. If they can't be, that's a minus. And as a political scientist who studied these issues for a little bit of time, I believe, and I believe this is true globally, public acceptability and public engagement are really the ultimate keys. How do communities perceive an option? And do they have a voice in its implementation? I'll tell you a quick story. This is Israel. Israel, since the 1990s, has aggressively pursued desalination. It really doesn't have many choices. That is a place where desalination truly fits. Drinking water for every major city in Israel is provided by desalination plants. They also harvest some water from Lake Kinneret, or what we know as the Sea of Galilee. But that water supply has also been diminishing as a result of climate change. So the desalination plants are actually used in part to replenish the Sea of Galilee. It's a very interesting plumbing system that the Israelis have developed. After the water leaves the cities and it's treated as wastewater, the wastewater is sent out to the rural areas of the country, and that is the source of agricultural irrigation, recycled wastewater. So they have a very integrated system. Israel accepts desalination as a necessity. They're willing to pay for it. However, that does not mean that there has not been controversies over where to site desalination plants. And there is a controversy right now. There's a proposal to build one near Haifa, northwestern Israel on the Mediterranean. And there's a lot of public consternation over the particular site that the government has chosen. We don't know what the final verdict will be on that, but it goes to show that even in places that might accept the technology, that doesn't mean they accept the siting of the technology. So you still have to go through these issues. So feasibility, cost, impact, and public acceptability. This figure on the bottom came out of an article that some colleagues of mine wrote a few years ago. And basically what we were arguing for is an integrated system where you would recycle wastewater, harvest rainwater, and use some wastewater from your household for your own garden and your own lawn, basically a completely integrated system. This is something that we think is an ideal, at least something to emulate, if not something that can be readily achieved in a hurry, but something that would actually be a low energy option to reuse and recycle every drop of water and also harvest rainwater for appropriate purposes. So let's talk about seawater desalination. This is a graphic that came out of an article in Science magazine a few years ago. And basically I like this because it underscores some of the major environmental and societal impacts of desalination generically. Energy consumption. Desalination is extremely energy intensive. So it's not a cost-free option. And if you're worried about climate change and carbon dioxide emissions, you have to ask yourself, where then are you going to get the energy to desalinate the water that you're having a deficit from because of climate change? So you kind of get yourself in a thorny knot. There are other questions. The cost, because it's energy intensive, it's also expensive. San Diego County, North San Diego County in the last 3 years built a desalination plant. Many of you know in Carlsbad, nearly $1 billion project. The water is about 3 times what we pay for water here in Irvine. But if you had no other choice, maybe that would be a reasonable option. I mentioned energy consumption. Seawater, when you bring seawater into a plant, you also bring little critters that are out there in the near ocean environment. That's called entrainment. And a lot of environmental groups are very worried about that impact from desalination. And then when you separate the water from the salts, what you have left over is called brine. Where do you dispose of that? It can have adverse environmental impacts. One solution is, as shown in this figure, what are called diffusers. You take the return flow and you diffuse it out to the ocean environment. You mix the brine back with the ocean water. Some argue that that's a very safe and effective way of disposing of the brine. Others say it creates a high concentration of salts in the near ocean environment, and there hasn't been sufficient research done yet to determine how harmful that might be to sea life. Would you want to live next to one of these plants? They're noisy, they take up a lot of space, and aesthetics is a huge issue in places like California, particularly in our coastal environment. And I think most importantly is this issue synergy with other sources, or in other words, do you actually mix and tie this solution into other options as well? If this was your only option and it broke down, and they do break down, it's a big piece of machinery, you're out of luck. So if this is one option that you choose, you still have to have some kind of plan B. And this is a problem that we face throughout the world, but particularly here in California. Whoop. Very briefly, the economics and the energy consumption. I like this particular study. This was done by a consulting firm. One of the authors is a friend of ours, Heather Cooley, who works for the Pacific Institute in Oakland. Her name's cited down there. But basically, this is a question of how many kilowatt hours of electricity is used for 1 million gallons of water as a result. And basically, local surface water is the lowest energy consumption, groundwater the next. You still use some electricity for groundwater because you have to pump the water upwards. Recycled water treated to non-potable levels. That's what we mean by tertiary treatment. Doesn't use quite as much energy, which is a good thing. Imported water, some of you might know, does use a lot of water because you have to pump it over the mountains. Here in California, to get water from the Delta to Southern California, you have to push it over the Tehachapies. So it's very energy intensive. Desalination of brackish water, energy intensive. Recycled water, the way it's done here in Orange County, in Fountain Valley, is also energy intensive, but not nearly as energy intensive as imported water from the State Water Project, which takes water over the Tehachapies, or seawater desalination. So these are just some comparisons. If energy consumption is your thing, if you're worried about that, probably a good middle ground would be recycled water. Or if you had these other sources available to you. The nice thing about recycled water, as we'll see in a moment, is in places like Orange County, we combine recycled water with local groundwater. We actually take the recycled wastewater and pump it back into the groundwater basin, which makes it drought resistant, drought proof. But there are some concerns. And again, this is the Carlsbad project in San Diego County. In the case of the Carlsbad plant, there is on-site energy provision. There was already a power plant there at the site where the plant was built. They have diffusers out into the ocean. Most importantly, in terms of cost, they have long-term rate agreements with the County of San Diego. And it is integrated with other sources. And there was a high level of public support, which we're not finding in Orange County equivalently. Why the high level of public support? Well, one possible explanation for the high level of public support is because the only other option that seemed to be feasible in San Diego at the time this plant was proposed was direct potable reuse, which is taking wastewater and directly utilizing it as a water supply source, not pumping it down into a groundwater basin, because there is no groundwater basin, San Diego County, of suitable size to hold that much water, but to simply put it into the distribution system. There was very little public support at the time for recycled wastewater. So it was a compromise. I mentioned Israel, and there are some international lessons that are important. Beginning in 2000, they've built 5 desalination plants that provide some 80% of the water supply, but it's not a panacea. The government's water authority contends that climate change will worsen water availability. And that's why they reuse wastewater for agriculture and they use drip irrigation. Yes, it's possible to grow oranges in the desert and use very little water in the process. The Israelis are pioneers at this. Jordan has subsequently adopted much of this technology, as well as parts of the West Bank, Palestine. And intensive water savings in Israel. Water conservation is practically a religion unto itself. And as I mentioned during the break to a couple of folks, there's broad consensus over water as a security issue. And that induces cooperation with neighbors. And in fact, Israel is currently planning to cooperate with Jordan on the possibility of building a desalination plant that would provide water for the city of Amman, Jordan, but would also provide water to replenish the Dead Sea, which is a resource shared by both countries and is a major tourist mecca. So These are reasons for cooperation. And I mentioned water conservation. Israel, some years ago, decided to provide a permit system for the allocation of water. They do not have such a thing as water rights in Israel. Water belongs to the state, and it's allocated. Its use is permitted by the government. And this map, which, by the way, you can retain these and print them off if you'd like. This shows the desalination plants, the supply that goes to the cities, and the connection then with the rural areas. So this is a very, very extensive plumbing system for an entire country. Land area about the size of New Jersey, with around 8.5 million people. Y'all remember Wilford Brimley, great character actor? I love this satiric advertisement. Reusing wastewater, Porcelain Springs. This was a joke when it came out, although many people thought it was a serious advertisement. But it was a way of basically telling a truism about recycled wastewater. And that is that people don't like it. They fear it, or many people fear it. We call it, some people call it toilet to tap. But the point of this satirical ad was to underscore the fact that, in fact, if you market it right, you can actually make it very attractive. And in fact, hint, hint, all water is recycled, okay? There are some concerns. We have here in Orange County, California, one of the world's largest, and in fact, the country's largest wastewater recycling system. If you've not been up to the groundwater replenishment system up in Fountain Valley, they give free tours. It's a marvel. 2.5 million users. All of our wastewater in South Orange County is sent to the water district up in Fountain Valley, and through a process called reverse osmosis, together with ultraviolet radiation, activated carbon, and chemical treatment, the result is a highly purified water that is then injected back into our groundwater basin, which makes it drought proof. It is costly, although not nearly as costly as desalination. It does have a high rate of energy consumption, though again, not nearly as high. Health impacts are a concern. Is it safe? The answer is it is safe, and it has been shown to be safe, but public concerns over its health had to be alleviated. And the Orange County Water District went to great lengths to establish the safety, and they still do. They work very closely monitoring the quality of the water, both coming out of the plant and also coming out of the groundwater basin. And it is well integrated with other sources. We get our water here in Irvine, our drinking water, not only from this project, but we also get some of our drinking water from the Santa Ana River. Some of the water on the Santa Ana River, particularly when it does rain, is harvested and percolates back down into the groundwater basin. So we get some fresh water supply, some recycled wastewater. And we do get some water from the Colorado River as well. So we still rely on traditional sources. Stigma and other concerns. This was a big issue when this facility was built. How do you overcome public concerns over the drinking of wastewater? And there's no simple answer to that other than the fact that the Orange County Water District established that they could do this project on time and within budget, and they did. That they would integrate it with other water sources, which, as I mentioned, they have. That they would employ advanced treatment methods. They wouldn't skimp on the way they would treat the water. and perhaps most importantly and most compelling for Orange Countyans. By doing this, we could ensure continued growth of the county. In other words, we know there's going to be more demands, even though we're going to have diminishing supplies. How do we reconcile both? And the answer is we reuse all of our water. This figure on the right is simply meant to illustrate how over time the amount of water, the purple being the groundwater replenishment system purified water, has eclipsed imported water. And in fact, this is a good thing. And in fact, throughout the year, more and more recycled water has been able to be injected into the system. 3 stages of treatment for those of you that are interested in the engineering facts. Primary treatment, the removal of suspended solids and organic matter. The Orange County Water District's groundwater replenishment system, if you've ever been up to Fountain Valley, and I encourage you to go, you can take a great tour. After they take the solid matter, the biosolids they're called, those solids are sent over, it's a few feet separating the two, to the Orange County Sanitary District. The sanitary district takes those biosolids and uses them as an energy source to reprocess the remaining wastes. So it's a very, very integrated system. And then secondary treatment, biological treatment. By the way, biological treatment means bacteria. This is why when you go by wastewater treatment plants, there's an odor. It's the bacteria doing their work. And then finally, the advanced treatment I mentioned. This is a good system. It was an expensive system when it was initially built, $750 million. It now provides about 100 million gallons per day to Orange County. At complete build out in another 2 or 3 years, it'll be up to about 130 million gallons. It reduces the need for imported fresh water. And that's a big bonus for us. And it reduces wastewater pollution. The more water you recycle, the less water you dump into the Santa Ana River and into the ocean. Some familiar faces, former Governor Brown. It's kind of interesting, at the end of the tour at the groundwater replenishment system, you get to sample the water. A few years back, I took a group of students to the plant. They're all still alive, as far as I know. No, very serious. Yeah, but there are public concerns. Remember, I mentioned earlier, public confidence and public engagement. In less affluent areas of California or of the nation or of the world, areas with environmental justice concerns, wastewater reuse can arouse mistrust, especially among underrepresented groups. This was an issue that arose here in Orange County, but the Orange County Water District and its allies were very politically astute. To make sure it would become accepted, they made sure that all options were assessed and compared. They didn't just go out and say, let's recycle wastewater. They said, let's do a life cycle comparison. To get 130 million gallons per day of water, we could build a desal plant. We could continue to import water from the Colorado River. We could recycle wastewater. We could pray for rain. Let's do a life cycle analysis of all of them. The praying, by the way, no problem there. Continue to do that. But in the meantime, while the big guy's doing his work, let's build a recycling plant, okay? So all feasible options were assessed and compared. The management agencies were perceived as trustworthy and competent, and that was because they engaged the public actively in plans to build this facility. The operations are transparent and continuously monitored. One reason they conduct tours is because they want people to understand where your water comes from. And the implementation is viewed as equitable. The water that is consumed in Orange County goes to underrepresented groups as well as affluent groups. There's no discrimination in who is targeted as the end user of the water. Public outreach, programs that emphasize operations, safety, and its benefits economically as well as environmentally, and its comparative advantages. Los Angeles, this is a lot of text here, but I want to walk you through this. Los Angeles has been struggling for years with how to deal with their climate impacted water supplies. Los Angeles imports most of its water, most of it from the Colorado River or from the Bay Delta, the California State Water Project. And as some of you know, historically, for the last 100 years, from the Owens Valley. These are all sources of water that are now becoming environmentally limited because of climate change. Colorado River supplies cut back, as we mentioned earlier this morning. The Owens Valley, the Environmental Protection Agency has ordered Los Angeles to put the water back in the Owens Valley to restore fisheries and also to restore Mono and Owens lakes because of air quality issues from dust in the Owens Valley region of California. The Bay Delta, well, environmental issues, environmental concerns over endangered species. Outgoing Mayor Garcetti has been a strong proponent of recycled wastewater. Finally, or at least as of a little over 3 years ago now, it looks like Los Angeles is maybe turning a corner. What is being proposed here is to take wastewater from the Hyperion plant near Santa Monica, which is the largest wastewater treatment plant in California. Add on to the Hyperion plant a very high-tech wastewater recycling facility, almost identical to the one we have here in Orange County, and then pumping the water into the San Fernando Valley and putting the water into the groundwater basin to basically reduce Los Angeles's dependence on imported water supplies. As you can see, there's been a lot of opposition historically, but they say years of drought, declining imports, and the high profile of a similar program in Orange County have softened resistance. People are accepting it now. So says the Assistant General Manager of the Department of Water and Power. By the way, this is the first article I can remember in the LA Times in which somebody said that LA was emulating something being done in Orange County. I just had to get that in there. I think that's really important. Anyway, but these are some of the issues. And there are lessons elsewhere. In the first hour, I mentioned Australia's millennium drought. During the millennium drought, Australia went to great lengths to employ public engagement to encourage the reuse of wastewater. This figure here shows a number of water agencies in the state of Victoria, the state whose capital is the city of Melbourne, second largest city in Australia, over 4 million people. And basically during the drought, there was a tremendous emphasis on the reuse of wastewater in virtually every water district in the region. That's what this figure is designed to show. Significantly, once the drought ended, reliance on recycled wastewater declined for potable purposes. People would still prefer not to drink recycled wastewater, at least in Australia. They'd rather use some freshwater supply if it's available. But they're still recycling water for non-potable purposes, including agricultural irrigation. So as in Israel and other parts of the world, wastewater is being used to produce food. That's a good thing. A cottage industry that grew up in Australia is this: harvesting rainwater in rainwater tanks. If you go to Melbourne or Sydney, it's almost a patriotic duty to have a rainwater tank in your yard. If you don't, your neighbors will admonish you. So you collect rainwater and you mix it with gray water, is what we call water coming out of sinks and washing machines, and some water that comes out of water closets, toilets, mixing it, and then you can use that water to grow vegetables in your garden and water your lawns and wash your car and do all kinds of domestic things short of actually drinking the water. But it means you need to replumb your house. And so if anybody benefited from the millennium drought, it's plumbers, plumbing contractors. So at any rate, big lesson there. This is something that we need to be thinking about in California if we're going to become serious about reusing every drop, not just large-scale projects like the groundwater replenishment system, but replenishing on a household level as well. Conservation. Here in Irvine, some of you know the Irvine Ranch Water District has been a pioneer in what is called a tier rate system. The more water you use on a monthly basis, the higher a per gallon charge you're put on your water bill. Okay. It's basically to encourage you to use less water, to conserve. And it has ended up reducing residential water use by at least 50%, if not more. Utilities can apply a property-specific water budget to a household. Irvine Ranch Water District does this. They know how much water you should be using based on the size of your property, its footprint. And you can even employ what's called a water smart billing system, showing residents how much water you're using compared to the average user within your area code or zip code, excuse me, your postal zip code, and compared to the most efficient household. Psychologists call this norming. We want to be in the norm. We don't want to know that we're using more water than our neighbor. You know, the joke was during the last drought, people were calling up Irvine Ranch Water District and saying, I must have a leak because my water bill is much higher than my neighbor. Well, turned out many instances, there was no leak. You were just using too much water. So you needed to conserve. So basically being able to calibrate your use next to neighbors. Easiest way to do this is to get rid of any teenagers in your home, by the way. That's the other thing that we learned in the lab. No, just kidding. Okay. And incentives to reduce outdoor uses, rebates for converting lawns to drought-tolerant landscaping. We've done this in Southern California. We did it during the last drought. Some utilities, Miguel Water District has been doing it currently, South Orange County. Las Vegas has done this in a dramatic fashion, as I mentioned in the first hour. They have reduced outdoor water use by 75%. And high efficiency landscape irrigation is important as well. A little known act way back in 16 years ago now, the legislature passed something called the Water Conservation and Landscaping Act. When you do build a commercial or residential property in California, the irrigation systems have to be high efficiency. And irrigation controllers, irrigation equipments, moisture sensors, all of those sorts of things are specially made for California's drought susceptible climate. So these are ways of conserving water. These are things that work. Tiered rate systems provide an economic incentive. Water smart billing systems so you can compare yourself to others, and incentives to reduce water.
Question,
This
Dave?
does not work. Go ahead.
Dave, I have a question. A couple of
Sure.
years ago, there were some legal challenges to the tiered rate, especially the increasing tier rate. Has there been any legislative action that could bring this up to date more?
Good question. There are some utilities that have avoided tiered rate systems because they don't want to penalize water users. As far as litigation, the courts have held that water agencies are absolutely within their reasonable rights to charge more for using more for two reasons. Number one, you are not paying for water. When you pay your water bill, you are paying for water services. You are paying for someone to acquire the water, transport it to your home, and then treat the wastewater. Those are not cost-free services. The more water you use, not only are you placing a greater burden on the system's supply, you're also placing a greater burden on the treatment because the water you use is sewage that has to be treated. So it's perfectly satisfactory as far as the courts are concerned. It's like paying more for putting a bigger burden, and it's equitable because you're not paying more if you're not using more. If you're conserving, you're actually getting a bonus, or at least that's the logic. This is not an effective way to encourage conservation. During the last drought, shaming or outing, taking pictures of people running their sprinkler systems when there were sprinkler bans. I love this caption here. Tony Corcoran canvassing Beverly Hills, all of West LA, really. Not everyone is happy. One woman, quickly tiring of Corcoran's lecture on conservation while she watered her plants, turned her hose on him. So anyway, yeah, you don't want to make people hostile and you don't want to make people angry. So norming rather than shaming is a better strategy. Although I know we've all wanted to shame our neighbors who tried to irrigate their driveways. I know I have felt that too. I'll have. I want to say some things about questions that have come up. What's the best option? And to me, as a political scientist, I would say acceptability is really a question of adaptability. Every innovation has advantages and disadvantages, as we've seen. Rather than look for the best options, I don't know that there is such a thing as a best option. Really, I don't. We should look for the most adaptive solutions, the ones that have a low probability of failure, that generate few negative consequences, that conserve resources, and that incorporate lessons from previous experience. I think the Native Americans here in California probably had it right. Don't take it for granted. Use it sensibly. If you look, and I just completed a study on this and a book that's going to be coming out later this year, I did investigations, colleagues of mine did investigation of what options are being adopted worldwide. And basically what it comes down to is that you want options that are publicly acceptable and adaptable. And that varies depending on where you are. Here in Orange County, and I really am agnostic about this. People say, oh, do you favor desalination? I'm not opposed to it, but I think it has to go through that screening that I mentioned. Feasibility, cost, impact, and public acceptability. We are probably better off recycling wastewater. It's the best option, I think, for us, and conserving and harvesting more rainwater. And we do a pretty good job of that during storm events. It's not going to be a panacea, but it's a good option for us. On the other hand, in a place like Singapore, which fears water security because its water supply at one time came from Malaysia, and there were fears that that might be cut off, Singapore has turned to desalination as a solution to ensure that it had abundant water supply for its semiconductor industry and also for potable uses. Desalination is probably a good option for Singapore, publicly acceptable. And as I mentioned previously, in Israel, also in parts of Australia, parts of the Middle East, where you may not have many choices, or South Africa, I mentioned that as well. So it depends. Countries want to be water secure. They want to make sure that their water supply is not subject to the vagaries of their neighbors, as well as to the vagaries of climate. I want to close on this note, because this is something I think is often overlooked when we talk about long-term constructive solutions. A lot of our problems involving climate change generally and climate change in water, as I've alluded to earlier this morning, are really problems that are caused by underlying conditions. And beginning in the 1980s, the World Commission on Sustainable Development, which was the first United Nations organization to actually use the phrase sustainable development, which has now become a common part of our language. They argued that the sources of most major environmental problems are economic activities, the depletion of resources, including energy, and politics. Three major issues. Poverty puts pressure on extractive resources through harvesting of timber, slash and burn agriculture, and the depletion of land and water sources. Overpopulation, putting additional pressure on resources, leading to their depletion and resulting in greater urbanization and thus greater energy use and pollution. And lack of governmental capacity to overcome poverty, manage development and resource use, and develop a pollution control infrastructure. I end with this slide for one very simple reason. People talk about what can we do about climate change and its impacts on water and deciding what options. And my answer is, first, solve the problems that underlie these conditions. And for me, I would say poverty is number one. If you want to fight climate change and you want to fight environmental degradation, figure out how to solve the problem of poverty worldwide. And if you can solve the problem of poverty, population growth will probably take care of itself. Because as we've seen, fertility rates tend to decline as countries become more prosperous. And if you can reduce poverty and population pressures, maybe governments can catch up to their own problems. And so the capacity of governments to manage things like climate change and water supply will also increase. So that's probably a good place to stop, and I'll open it up and any final questions, comments you all have.
While everybody's thinking about that, I have a question from one of the Zoom people. Do you know about the Doheny project? I assume you do a small scale desal proposal, and I think fits perfectly into the situation you've been talking about. If you just say a word or two about that.
It does. And in fact, in my book, I talk about that. Small scale, renewable energy driven desalination is a very sensible idea. It's being adopted in places like Malta, Indonesia, other parts of the world. It's a good solution because it really speaks to this issue of poverty and underdevelopment. It's something that's small enough scale that it can be utilized in a developing society. And it's not looking for a one-size-fits-all panacea. It's trying to develop an option that makes sense on a locally accessible scale. But it doesn't work everywhere. It's probably not going to supply copious amounts of water.
I'll just get the microphone. We had.
It seems to me that Avalon, Catalina, put in the desalinization plant a few years ago.
They did.
How did they accommodate, or what's the effect of this brine that you're talking about? And I guess is energy consumption a major concern there? And lastly, what do they have for plan B? Great question. And in fact, Catalina does rely mostly on desalination. Three things they have going for it. They're an island, some distance off the coast. Brine disposal has not proven to be a problem.
they can diffuse it in not the near ocean environment, but actually a fairly deep ocean environment. So the environmental impacts thus far at least appeared to be negligible. Secondly, Catalina has a relatively small permanent population, a lot of tourists, of course, but we're only there for short periods of time and then we come back to Orange County. So small population, so the amount of energy that has to be used for the production of the desalinated water is, I won't say it's inconsequential, but compared to other options that would otherwise be available to Catalina, it's manageable. And so that's basically the answer. And it's a system that is fairly small in scale. It's not producing vast amounts of water because there's not that much of a permanent population on Catalina to sustain. Yeah.
Can you tell us, please, how much of the Colorado River water does ever get to Mexico?
Yeah, it's a great question. So Mexico, under the U.S.-Mexico Treaty of 1944, Mexico is guaranteed to receive 1.5 million acre feet a year of Colorado River water. Currently, the average annual flow of the Colorado is somewhere around 11 to 13 million acre feet a year. So a fairly sizable percentage is supposed to go to Mexico. In any given year, that has meant that the United States has had to find alternative means of providing that 1.5 million acre feet. In Yuma, Arizona, there is a desalination plant that was built by the Bureau of Reclamation. And the whole purpose of that, Yuma, as you know, is inland. It's not close to the Sea of Cortez. It's not close to the Pacific. It desalinates brackish return flow from agriculture in Arizona and Southern California. That brackish return flow from irrigation is desalinated, and that is sent over to Mexico to make up for the deficit in the 1.5 million acre feet that we are obliged to provide under the treaty. The treaty doesn't say how to get the 1.5 million acre feet to Mexico from the Colorado. It just says to get it to Mexico.
I think with that, David, we'll have to let you go back to work here. But thank you very much for coming. We always appreciate it. And we'll see you next time.
You got it. Look forward to it.